Hello, everybody, and welcome. Thanks for joining us here today for the 2 o'clock Eastern Standard Time session here in the IoT manufacturing world and supply chain day. I'm your moderator today. My name is Ira Sharp, a co-founder of the Industry 4.0 Club, and I'm joined by a great panelist team here today. And today we're going to tackle the topic of AI-powered quality control in manufacturing, and really look at leveraging IIoT for zero defects. So I'm personally really excited about this topic. I think it'll be really interesting to dig in and really look at how AI can be really applied to quality control, what that looks like, and what it means. As I get started here and the panelists introduce themselves, I'd like you to take a minute to take a look at the interface. If you've been with us all day, you probably know a lot of the tools in the interface that you're dealing with, but we do have the chat function. And if you can go ahead and use the chat function, I'd love to know where you guys are from, like around the country, around the world, wherever it may be, just to see what kind of audience we have. And then also, as we go through this, of course, we do have a couple of questions, and we're going to have a nice dialogue amongst us as a group here. But in addition, there's the Q&A panel on the right-hand side. Go ahead and use that for any questions you have, and we'll make sure we try to get to those here at the end of the presentation, or not presentation, but conversation. So with that, all of this wouldn't be possible without our sponsors, and the sponsor here for this particular section is Trek Omni. And with that, I'd like for the speakers to introduce themselves, and we'll go ahead and start with Dr. Eric here as the CEO and founder of our sponsor. So, Dr. Eric, can you please go ahead and introduce yourself?
Yeah, for sure. Thank you very much for the opportunity to participate in this panel. Eric Volkering, founder, CEO, Trekonomy. We're basically revolutionizing the way of how enterprise resource planning works in multiple verticals, so logistics, in industrial, and healthcare, and excited to explain more about what we're up to, and I'm very glad to participate, and thank you again for the invitation.
That's awesome. Thank you, Eric. Really appreciate it. Next on my list here is Heather. Can you give us a quick overview of who you are, where you're from, and anything else you'd like to share?
Great. Thank you so much again for having me. I'm really looking forward to the conversation. Heather Saikoski. I lead our industrial and process automation business in North America for Schneider Electric. I think many of you know the Schneider name. We are focused on providing energy and automation solutions. And I think the key here is for energy efficiency and sustainability. I have 25 years in the industry. I'm a process industrial engineer by schooling. I've worked all over the world, and this is near and dear to my heart, this topic.
Yeah, I saw that in your bio there, and it really does seem like you really do key in not just on the business aspects, but how it actually all pulls together holistically. So it's really exciting. Thank you for being part of the panel. Sarah, you're on the next here on the list.
Sure. Hi, everyone. I'm Sarah Morgan. I currently have the privilege of leading digital for North America supply chain at Kellanova, and I have the best job ever. So I get to work with our manufacturing and supply chain leaders, our operational excellence teams, IT, engineering, and my favorite, directly with our frontline teams as we implement technology to transform our manufacturing and supply chain. I have about 25 years of experience in the healthcare and CPG verticals, leading teams to develop and deploy software systems and lead kind of the work systems to adopt those.
Awesome. You don't hear that very often. I have the best job ever. So someone's gonna have to raise their hand and say, hey, am I one up in that or whatever else? So Marcia, you're next.
Hi, I'm Marcia Gabois. I'm president and general manager of Adherestra. Prior to joining Adherestra or starting Adherestra, I was the president and general manager of a company called Indusoft, which was acquired by Invensys, which is now Schneider Electric. I've held many positions. I have over 35 years in software. I come mostly from the software, but beginning in AI in the 1980s with symbolic AI, dealing with expert systems in manufacturing, to the past 25 years being in industrial automation on stuff like HMI SCADA, predictive maintenance, OEE. So that's my background.
Awesome. Thank you so much for joining us. And just doing the quick math here, we have well over 100 years of experience between us. I don't know if that means we're wise or we're old, but maybe it's both. I'm not sure. But I think we have a good bit of understanding amongst us to tackle this great topic here. So again, we're talking about the topic of AI, and we're looking at how it's powering quality control in manufacturing, really leveraging IIoT, and how this can all play together. And to get things kicked off, what I would say is, Heather, can you give us a baseline and what the intent of quality control is in manufacturing? Like, why is this important to get started with, and then we can look at how we can improve it with AI and these other tools.
Super. So maybe just a couple things. I was reflecting just on some recent investments that were made for some schools in South Carolina, and it was all around innovations in technology. So I was thinking, really, there's almost every part of our life that has been impacted by innovations in technology. So just kind of sit with that for a minute. And then I think a lot about as well about empowering our people with data for real-time accurate decision making. I mean, that's what it's all about. So when we look at our manufacturing landscape, we look at quality control because that's I would say the most vital role, ensuring that we are delivering products that meet the standards of all of our customers. Quality control is fundamental in manufacturing. It ensures that we're running our lines smoothly. It's ensuring that we've got the right products possible, that we've got the right capacity. So when we're looking at just not only our own internal, but our customers' processes, we're trying to find how can we optimize, and quality control is the key function to that. And then also just the last thing is that when we look at ensuring quality and that consistency, we're building trust. So we're building trust for our customers. We're ensuring that we're delivering what was expected and so forth. We'll talk a little bit later a bit more about smart factory as we're seeing a lot of the investments, the reshoring effects that are happening here in North America. I think smart factory application of innovations, tying data digitally together could not be more important.
Thank you, Heather. Thank you. So, when you look at all that, I mean, that's really great, and thank you for that understanding and kind of where you are and things. Marcy, when you look at everything in quality, and we're looking at how we can improve things, we have to measure it. So, what processes would you say were used today for measuring quality to really help us improve it overall?
Okay, there are various methodologies that are used for quality control to improve quality controls, like Six Sigma, which is a management technique intended to improve business process by greatly reducing the probability that an error or defect has occurred. There's also total quality management, which can be described as more of a managerial framework designed to prioritize customer satisfaction and engaging employees to fix that customer satisfaction. There's always the statistical process control, which is obviously the statistical technique for quality control for process and production. And then Kaizen is an approach to creating continuous improvement based on the idea of small, ongoing positive change can make a huge impact on the business. And it's the core of lean manufacturing Toyota way. There are so many other methodologies like ISO 9000 standards, failure mode and effective analysis, lean manufacturing, agile quality management that collectively contribute to the quality enhancement knowledge and landscape. But when you add AI to it, it makes it more fascinating because between having the traditional techniques for quality control and using AI to assist you, it makes it very compelling argument.
Well, that's quite a bit. There's a lot going on there, and then you add the AI element onto it, and it adds, I'm sure, even more. Eric, thinking about everything that was just said and really the overall current processes, where do you see AI really impacting the improvement of quality and measuring of quality and these kinds of things?
Yeah, I think there's multiple waves to AI, right? I think the first wave, well, you go back 40 years of expert systems, right? But the recent wave has been very much around deep learning, machine learning in the cloud, right? The data analytics of data later, 6,000 miles away, through some dashboard to see where you messed up beyond the point of any impact, right? Close loop impact, I should say. And so I think that's the paradigm where the industry is locked into, right? Like, deep learning in the cloud. I think where we differentiate Triconomy is really a distributed agent-based intelligence, right? Because you want to have contextual information at the right time, right place, to the right person, right? So, frontline worker needs to be equipped to optimize activities, right? Versus somebody in mission control 6,000 miles away 3 days later. And so we bottom up change the paradigm artificial intelligence, which means we do open, like there's certainly value for deep learning and cloud AI, right? And certainly have our open AI integrations to a very intuitive way in data, right, and all the good stuff. But where we see truly opportunity is actually at the very low latency solve issues, and that requires changing the paradigm on not just AI but even cloud computing, right? So we do liquid computing. Computing needs to flow, but needs to go to make decisions at the low latency level, right? And the first line of defense is the frontline worker, right? And that's who we equip with the data. Or the autonomous workflow intervention mechanisms, which sometimes is a light bulb, sometimes it's a voice. I think the first wave of AI in cloud computing over the last 20 years, and most recently AI in the last 3 years, has been very much focused. I think the value is now beyond that point. Everybody gets it. Yeah, I can get insights from the cloud and big data. I think even the guy that put big data is no longer using the term big data. I think I saw a paper the other day that talked about small data. Because that's, if you're early on, the data is smaller, right? And then, if you aggregate everything in the cloud, you have a lot of data, and then it's like, where's my insights? Well, guess what? If you tackle it earlier, through distributing data, you get more relevant data and more easy. So that's what we're up to. That's the And
that's great, Eric. Thank you. And it's funny. We talk about big data, and like you mentioned it, and in a way that I always think about it is, data is great, but data is data. And making it information to make it actionable, intelligent decisions, and how you can improve systems and operations and whatever it may be is critically important. And what you're saying is, hey, doing that at a more localized level, doing it at a fast level, there's a lot of advantages there. There's a lot of niceties there. And it's interesting too with what I heard so far. The frontline worker has been front of the line here, so it's been a really important piece to the whole scenario, and that's great to hear as well. So looking forward, if we are looking at AI, and we're looking at these existing processes, because these processes have existed for a while. Like quality control isn't new; it's something that's been done for a while. We add in AI on top of it. Like, how does that all work? What are the things that need to be considered before we actually jump right into the whole idea of adding AI into manufacturing as a whole? Sarah, can you give us some insights on that?
Sure, I'd be happy to. So essentially, you need to first figure out what is the problem you're trying to solve or the advantage you want to obtain with AI. So obviously, building a business case is important before you start with the technology. But I would say one of the things that we often do not well is trying to optimize or digitalize a process that isn't stable. So I would say that's the first thing you need to look at is, do you already have a stable process to start with? And then obviously data is important. In my vertical, which is food and beverage, we have critical to process and critical to quality parameters that we look at. So you would want the history of that data to feed into a model potentially, and real-time sensing technology to capture some of those points. And then I think you would also, in our case, need raw material information, as there's lots of variability that comes with, rice or wheat, some of the products that we use to make our food. But altogether, you want to get the data out and then really have the capability of the teams to interpret that data. So we mentioned statistical process control. That's one of the ways that we can track that we're doing what we're supposed to be against our standards. So you need that governance and change management process to make sure the data integrity is there, and then the ways of working to adopt and put into place the systems. But I would say then you'd let the algorithm and the machine model do its thing. So analyzing the data to identify different patterns or deviations, correlations that the human brain may not make automatically, and recommend set points or ideal running parameters. But a lot of times before trusting the recommendations from machine learning models, we run in co-pilot type of mode, where the frontline teams would actually make adjustments. And the goal eventually perhaps would be full closed loop process control. So I think the takeaway is really know your process, know your current state, the capabilities of the team in order to use data to make effective decisions. But the technology itself complements, not replaces the need to do traditional hard work of continuous improvement.
Thank you much there, Sarah. Can you confirm my microphone's working? Because you might have seen I had to wire in. I just want to make sure I'm still good.
You're good.
You are.
All right. Thank you very much. Thank you very much. There was a little background noise. I'm not sure if it was me or what it was. Thank you. And I did have to disconnect, so I missed part of that. But I think it was really great because you set this foundation of kind of like where we are, what's going, and then what are those things, and how we can jump up to that next level. What are some of the, I guess, looking forward, Marcia, is there some real world examples that you can give us in this area of AI and how it's improving things?
Well, I mean, I can give you some real world experience from my point of view. And I think that we have to look at, like Sarah said, I'm going to play off her because I think she had it down correctly, is we really boil it down to 3 Ps, which is the problem that you're trying to solve, the persona, and the process. What I mean by that, you have to define, like Sarah said, a clear, suitable problem for AI to solve, and you need the right people involved. And if the people aren't adopting it and are not working with it, and the people are not involved in the situation, it won't be successful, I guess is the best way. And it has to be everybody from not just the operators, but the leadership, the IT, finance, everybody plays a role in this. I also think that in the process, you have to approach and identify a problem, the right way to tackle that problem with AI. You need to understand whether the data can solve the problem that you have, the data that you have solves it. So one of the biggest problems I see is with the quality of data. And I don't know if the other panelists see the same thing, but we seem to get a lot of AI application. People really want to do it, but the data isn't clean. It's not correct. So AI applications really does rely heavily on this availability of quality of data, both historical or product defects, equipment performance, and process variations are all important part of the data. Another big consideration is ensuring that the algorithm is trained on the data that represents the problem that you're trying to solve. There are a lot of algorithms out there, so you can use, when you're training your model, you can use synthetic data, which represents real data sets. However, eventually you will have to use real world data to validate your model and make sure that it works correctly. Another thing, in addition, you might want to you have to continuously monitor it. Things change. You have to retrain your model all the time. Whether it's new data, whether it's new processes, whether it's changes in your manufacturing, whatever, you constantly have to retrain the algorithm, retrain the model with new data, and address issues that are, that might change because of the way your business is being handled. Another consideration I always say is that AI systems must be seamlessly integrated into your existing environment, because those traditional systems actually are the ones that usually have all the data collected in them. So it has to somehow connect up. And the last thing I would just say is, you have to have the model or the AI system be explainable or transparent, especially in critical processes like quality control. Understand how the AI reach specific decision builds trust and facilitates the easier acceptance by the operator, because they'll know how the decision was made, and so they'll adopt it better. So those are some of the things I see.
Yeah. So thank you very much for that overview. And yeah, so what I heard from that is number one from Sarah's, and then you reiterating. And I think this is so paramount, so paramount. I mean, it's kind of 101, but you need to have a problem to solve. You need to have a clearly defined problem. How are you going to move forward? And without that, it's really hard to define if you're making progress or what the end state is and what you're trying to go to. And then you mentioned something else, and I believe this tied into what Sarah said as well. And again, I apologize, my headset went out for a minute, but it's really having the buy-in from the organization, because without that buy-in of the organization, it becomes a checkbox, right? Maybe not so much here, but in so many different digitalization projects or so many other high-level projects, it's just, if it's this little sandbox thing where you give somebody some funding to go do something, that's great. And maybe we can get to the board meeting and we can say, yes, we did that and we did well, whether it's sustainability, whether it's increasing quality, whatever it is, but tying it into the financial results and having it be meaningful to the overall operations is so paramount, all the way down to the operator, because as was mentioned, AI is fantastic. All these things are fantastic, but without validation, without actually knowing that it's truly improving what you want to improve, and the person that's going to know that is really that operator, what use is it, right? It's important that it bolts on, and it's not a replacement. It's a tool. It's an adder. It's something to assist in this regard. So we've talked a lot about the tech and kind of some of the background here. Heather, can you give us maybe some real life examples of AI in manufacturing and some places that it's been used and things?
Yes, and I really appreciate how you just summed that up. And the last comment was trust, and that makes me kind of lead into culture. A lot of this is around culture as well. And going back to, what does a smart factory mean to Schneider Electric? And I think about, we talked energy efficiency, reliability, we talked innovation, we talked availability, and it's that optimization of that end-to-end efficiency and the asset reliability. And we use EcoStruxure, for example, for the industry, or integrating all of the innovations that we have available, whether it's the IT solutions and the data analytics across the entire manufacturing operations. So myself personally, I just was in Monterrey, which is what we call kind of a lighthouse or smart factory in Mexico. I welcome many as well if they have any interest in seeing whether it's Monterrey. We've got another factory in Lexington, which was referenced at the beginning of the session, where we have deployed, or as we like to say, we've drank our own champagne, where we're using AI and IIoT in our own factories. When you look at also sustainability, I talk a lot about this because I think that there's three pillars, or the trifecta, that you really have to have, and that's automation, electrification, and digitization. So integrating in open platforms, utilizing the architecture, or if we're using our Aviva software platform, you have to have automation to have software, and vice versa. We can deploy the AI algorithms and analyze all of that data, which we were just talking about. We can collect all of the information from the sensors or the devices and get all of that real time. But as we kind of analyze that data, we can then identify, do we have a defective product? How do we, again, going back to that comment of quality. I think the thing also talked about culture, trust, but what I felt when I walked the line is that you have really incredible professionals that are leveraging this, unification and finding areas of optimization and reducing, let's say, failures, or they're finding ways to be proactive with their maintenance interventions before the defects occur. I mean, there's this excitement that happens on the floor. So then again, I think that in turn creates the openness to drive more innovations across the asset. I've said this also before. I haven't personally been to Lexington, but I will be going. Again, if anyone wants to go with me, open invitation is there to see firsthand. But we have an individual that's been with the company for over 40 years. He doesn't even have an iPhone or a telephone, but here he's operating probably one of the smartest factories in the world or in the US. So again, I think the power is you can continuously learn, you can continuously improve over time. We've got the algorithms that can gain the insights. We have the technology that we're deploying. We're drinking our own champagne and we're seeing the results and the people are excited. And it's a beautiful story.
Thank you very much. So I love the culture piece of that, and then you described it as excitement, leads to really the openness to really deploy it and embrace it and these kind of things, and it's really interesting. I also like the fact that we skipped right past the Kool-Aid and went right to champagne. So it's not drinking our own Kool-Aid, we're drinking our champagne. Heather, sounds fantastic. Sarah, in what you're doing in your area, do you have any examples and real life examples of how AI is helping in manufacturing?
Yeah, I mean, one that comes to mind based on what you just said is vision systems. It's critical in the food manufacturing process that we are able to detect, defects or anomalies before the food gets packaged and shipped out. So we've installed cameras, sensors on the lines to detect those products as they're going down the line, both the kind of in-process food and the finished food. What I would say, though, as a learning is a watch out if you have a vision system set to your parameters for what good looks like that are too tight, you can actually end up with rejects for good products that increase the scrap, which is something we don't want to do just due to that vision system. But it's a good example of how you can relatively inexpensively install some sensors, some cameras, and eliminate potentially someone's job who's sitting there staring at the product coming down the line to make sure it's good before it gets out the door. But calibration is definitely important, and having the skills, I would say, within the facilities to calibrate those systems is important as well.
That's really interesting, and it's interesting you mentioned kind of how the idea here that these systems, while they're great and they can improve things, they can also potentially cause false red flags or maybe these kind of things, and they really needed to be tuned in. And again, I think it was already said, but it's really why you can't just let this stuff kind of run amok. You really need to have a skilled operator still there with it, and it's to assist the operators, assist the system that needs to have a watchful eye over things to overall improve the operations.
I think the skill set changes just a little bit too, Ira, in terms of before you may have been watching the food and plucking it off the line in our case. Now they're more of a quality control person, right? Looking at it, making sure that the system is working, plus the food is good.
And that really improves kind of the probably the intentionality of the work as well, because
Right.
you're giving somebody a more skilled job, which they would probably like better. And I can speak a little bit to that as well, where I've worked in some facilities and a company I'm associated with, and they're picking products up and putting them in a box, and that's great. But watching them come off the manufacturing line, that's great, making sure they're quality, and but actually taking that product and putting it in a box, over and over and over again, that's really the last mile piece, and it's not something that somebody wants to do. So it's the same thing where you can now take that person, you can redeploy them and have them do essentially more meaningful work. So
Right.
it's fantastic. So all right, so depending on how fast these productions are going, I know the speed of this analytics can become critically important. And when you're talking about speed and you're talking about AI or you're talking about anything, having things be decentralized become a little bit more important, and being able to commute kind of on the fly. And Eric, I know this is kind of like near and dear to your heart. So the question I would have for you is, in general, are you seeing AI or this topic in general always being something at a higher processing level, or is this something that can be more of an edge play or more of a distributed play? Oh, I think you're on mute, Eric.
I apologize. And you're right. implies thinking of, you have cloud computing and you have edge computing. And in the history of computing, that's how the world works, right? The pendulum goes from mainframes to PCs to cloud computing to edge computing, and depending on the cost of computing and or the cost of communication, right? And so I think the answer is fundamentally what we've done, where we broke that paradigm, right? So we do liquid computing, and in some times it makes sense to do it at the cloud, right? And in other times it makes sense to the edge. But the center of the universe should be the frontline worker, and that decides the KPIs you optimize for. That decides where computing happens, right? To kind of link it back to your previous question on applications of AI. What we've seen is for the front worker, the bigger the data becomes big data, and the more complex it becomes to distill information from it. And so and to link it even further to the remarks that were made before, that at the end it's all as good as the data that you put in, garbage in, garbage out. The weakest link of the chain is the data you have, right? And so Triconomy is the only fully vertically integrated solution provider that goes from atoms to bits to neurons, right? And so we revolutionize technology where we can measure more data points than other companies are able to do, and that allows us to get contextual information relevant, where sometimes at the edge we make the decisions, or sometimes deeper, like if you have a pump and you measure a lever position and you measure temperature and the pressure and the vibrations. Each thing in isolation might be perfectly fine, right? Like, maybe there's a flow issue, but guess what? The engine isn't on, and therefore there's no flow. And so, why send the data 6,000 miles away if that can be solved at the edge, right? And it's not just it's all dimensions, right? It's battery life, it's cellular, it's so the answer between edge and cloud is not as rigid, but certainly that's the paradigm the last 30 years of the world and the history of computing, where it goes back and forth always.
Yeah, and it's funny you say that. Sometimes when you look at all this, it's important to have, of course, the compute right there. You don't necessarily need to send it all over the place, and so it's a little tongue in cheek, but it reminds me of just the kids joke. Like, is your refrigerator running? And you're like, of course it's not running. Like, oh, you better check it. Get the food out. It's not running down the street. No, it's physically right there. You don't necessarily need to. Yeah. To look on your energy monitor in your, for your house or whatever it is, to know that it is or is not running. Kind of to your point of looking in, not necessarily in manufacturing, but a real life example sitting in your house, whether the refrigerator is running down the street or it's running in your kitchen. You don't have to look at your iPhone to know that that's what's happening right there. Now, getting an alarm is fantastic, but you open up the door, the light doesn't come on, that there's a challenge, and that's right there directly at that edge device. And I know that's a little different than the compute that you're talking about, but from an overall warning system or sensor or whatever else it is right there at that elementary point, it's great. But you can still collect that data and you can do other things with it. So
it's a very relevant example because it's human-machine interfacing, right? Like there's two aspects. It's the AI aspect in the interaction with people to solve the KPIs you're solving for. Right, and it's a perfect example. It's a trifecta of man, machine, and units of commerce. And when those things come together, optimization can happen. It needs to happen at the time many times, but not always.
And hopefully you don't have that problem. Hopefully it's always good. We don't have to worry about those kinds of things. But inevitably things will become a challenge, and we'll have to worry about that kind of stuff. So, one of the things that I think is interesting, in having these kinds of conversations over several years within the company, within the Industry 4.0 Club, and just general conversations like this, is there's always this bridge between, okay, I have data, I'm going to do AI. We always talk about visualizing the data, and then, we really take a look at it and we go, we've been doing this forever. We've been doing this for 20 plus years. Marcia, I know that this is kind of like your bread and butter and kind of like where you got, built up a lot of things, but what is this structure different, and how is it different than like an existing system like a SCADA?
Well, Ira, you're correct. SCADA has been around collecting data as long as we can remember off of devices, sensors throughout the manufacturing environment. But it does provide a robust foundation for AI applications that can effectively utilize the in-depth analysis. Now, I don't think SCADA data is the only data you should use. There's a ton of other data in the plant that should be incorporated in for analysis. But it is a good platform to begin to detect, identify patterns and anomalies, offering insight that potential variations in product quality or process efficiency. It also is a great location for historical data that can be valuable for training your AI model and machine learning. So the past performance deviation and the outcomes and can contribute to inform an AI model what the realm of your quality control issues are. Another thing I think that's fascinating when you put SCADA is if you had SCADA with AI next to each other, it could extend to implement adaptive control strategies. I know there's a whole discussion back and forth between open loop, closed loop, whether you want the system to actually change and adjust your process parameters. But I mean, when you do have the analytics right away, that's a decision you can make in the design of your stuff. But it does allow you to not only collect, do everything that the SCADA system does, but to add that AI component that will allow you to really use the data in a more efficient way. So that's just some example, but you can go on and on. There is so much synergy between SCADA, HMI system, and an AI framework within a manufacturing context, that will complement each other and actually help you achieve your goals.
So with that, I mean, do you, what does that architecture look like? Without going too deep, but is the SCADA is going to have one data set? Do you see the AI using a completely different data set? Are they the same data set?
I think it utilizes, I think that the AI, this is my opinion, I'm sure you'll get others. However, my opinion is that it's one component of the AI framework of data sets. So the SCADA and let's say your manufacturing performance of that equipment data. There's so many other, your production data, your other stuff. There's a ton of data that needs to be consolidated and obviously cleansed. I mean, I'm going to avoid the whole cleansing of the data and all the other stuff, but all that data needs to come together in order to do analytics that I think that can help your whole processes. But SCADA is one piece of it. It will, it is actually a substantial key part of data.
Thank you. Heather, I saw you unmute. Did you have something to add there, or were you just unmuting?
It was more so just I agree. I think that I always see that kind of common thread as well.
Okay. Okay, thank you very much. Yeah, I appreciate that. So, what we've explored here, I think, is the bright side of everything, and how we've identified how things can improve. AI can help us improve. They can help us get to that next step. They can help make more meaningful work. They can help improve the culture. We've explored a lot of things, but not everything can be only positive, right? We have to play the other side of the coin. What are some of the gotchas, some of the things to consider, some of the things that maybe we should dig a little deeper on this. Sarah gave us a little bit of an example of this, like looking at, hey, if you're looking at the material or your finished goods coming across the line and your vision systems maybe dialed in a little too tight or whatever it may be, and maybe rejecting things that are actually okay. I don't know if there's any other examples or other just general ideas of some gotchas that AI can present in manufacturing. And Eric, why don't you kick us off if you have any thoughts on the subject? Well, Eric, you're on mute again. We gotcha. Okay, go ahead.
Yeah, especially in manufacturing. I mentioned earlier the trifecta of man, machine, units of commerce. That's where the action happens and KPIs gets optimized. This is of course especially when you see that, right? First line workers working with machines to prepare a unit of commerce. And there's many places where when you do AI, you risk either creating false positives or escapes. And what we've seen partly time of liquid computing can help by looking at it of a more holistic level, where it's obvious. Because when you really do edge computing and you look at it in a silo perspective, decision making isn't the right optimization to go after, right? But if you look at it from a combination of other factors, you're able to do optimizations that otherwise you cannot do. And so, but at the end, it's always false positives, escapes, right? Like you make an assessment, you're going to drive conclusions from this assessment. Either you make the wrong assessment, right? Or you make the right assessment. I say it the wrong way. It's either false positive or false negative. So yeah, many examples there.
Yeah, so I got it. So, the general idea is that AI is great until it starts making mistakes. And the problem is, I guess, if it starts making mistakes, it probably makes them a lot because it thinks it's right? I mean, that's not exactly what was said, but that's kind of what I heard anyway. So if it's wrong and it thinks it's right, it's a whole lot of right. And if it's right and it's wrong, it's a whole lot of wrong. So maybe it's like talking to my kids. It's late in the day, and you just okay, yeah, you can play the iPad for an extra 10 minutes. And then all of a sudden, every single night, well, of course I can play for the extra 10 minutes, right? Not that anybody can relate with that. I saw a couple of chuckles, so I must be the only one that ever is related with that. So, Marcia, is there anything that you can think of from an AI standpoint in manufacturing that is a gotcha? I understand the idea of getting consistent wrong responses, and then maybe you can go back and refine the algorithm and tune it in. Are there other things to consider as well?
Yeah, I think there's some things you have to consider. Like, there is an implementation cost. Okay, no one can deny it. AI, it's expensive to configure and update and keep these models up to date. I'm not saying it's not worth it. I'm just saying you have to be aware that there is some implementations, but you can always implement in stages. So begin by keeping it manageable, have a crystal clear objective of why you're bringing this thing, bringing this AI into the quality control area game. You also, it's about, if you want to improve quality, you need to pinpoint specifically metrics, defects, inefficiency. You aim to tackle with this measurable goal of putting AI in. I also think you need to get to know the ins and outs of your manufacturing process. I see a lot of people think it's AI for AI's sake, that AI is going to make a big impact, and it may not make the impact you think in the area that you're looking at. So you really need to understand your whole manufacturing process and where the most value comes from. As I said before, I think data silos and disconnected equipment, some of the legacy systems aren't even on the internet, they're not even connected. You really you need to be able to access the data you need in order to solve the problem that you need. And sometimes they are locked up in disparate machines. You'll have an even harder time implementing, some AI solutions when you don't have that seamless data sharing capability. I also think once you start putting in IIoT sensors, devices all across production floors, manufacturers can generate massive amount of data, but you need to set a proper infrastructure and data management practice to clean up the data, because sometimes it's not as clean or efficient as it should be before you feed it into the AI algorithm. And you also, once you start connecting all these devices, sharing all this data, you really have to start looking at the security and cybersecurity issues behind collecting all the data and making sure, because, obviously the data is important to people's business and making sure the practice. I go back to the people again. It's adoption and change. You have to make sure that they're properly trained, that they're seamlessly adopting it, that it's making a difference on their productivity. If it doesn't make a difference, it will never be used correctly. And then obviously, like I said before, you have to regularly check up on this thing because it's new data, new processes. So you need to be retraining it. So that's where the cost keeps going in, because you have to retrain it. It's not like, oh, I did it, here it goes, push it out and hope that in 10 years it'll still be working correctly. You really do have to keep it up to date. And like I always tell people, it's more of a journey when you get into the AI than it is a final, here it is.
Sounds
so
good. Okay. Yeah, sounds good. Did someone have something else to add? No, I thought I heard somebody jump in. Yeah, it's a journey. I think is a good way to put it, and I think you took us down a good journey there. It is great, right? It can add so much, and it can increase productivity so much, and it can provide more meaningful work and a better culture and all these other things. But at the end of the day, you got to be ready for it. You got to have that plan. You got to have the processes in place. You got to have policies and procedures in place so you can cleanse that data. All the things that you mentioned, I think are absolutely paramount. So it's always the good with the bad, and particularly in the manufacturing space, we know that it's not necessarily the fastest area to embrace change, right? We all know that. So it needs to be calm, cool, and collected to really pull it in. And when it goes in, it needs to be successful. It needs to be really part of a holistic vision and mission to be accepted. So, with that, so maybe even going a step above everything, but, Sarah, with your experience, particularly with where you are and what you do, what do you see as AI and providing the most value, if you had to really kind of quantify it, and why? And we're going to hold you to this. You got to tell us absolute. No, it won't be but the best of your thought right now, and kind of like where you think AI will have the biggest play and the biggest value.
Yeah, I mean, so most value is very subjective, right? But not particularly our quality example that we're talking about, but I really believe personally that enabling supply chain resilience through things like digital twins, simulation, and then supply chain management with forecasting demand, which is typically an area that isn't the best, and then optimizing inventory, getting our food out the door on time is going to be really impactful. But I would say practically where I've seen the most value at Calanova is from reliability maintenance. So putting in monitors for sensors on our critical assets. We have software that is looking at that data and providing alerts to our plant teams that can take quick action to address issues before we get a true breakdown. And I would say that from a leadership standpoint, it's also the one that we can quickly prove value by showing what would be the cost of an asset and people's time to fix that. So more cost avoidance results coming out of predictive or just continuous monitoring of our assets. And I would also say, even without the AI component, you get that immediate payback in terms of avoiding people going out doing inspections. The machines are doing that for us now. But with AI comes added advantages as well. So that really, I would say, take it to the next level in terms of optimizing maintenance in total, getting ahead of or maybe reducing our routine preventive maintenance activities and parts inventory in favor of what the model is going to predict.
Yeah, that's good. And, thank you for that. And, you mentioned that supply chain resiliency, I think that's an awesome title there. And, I've seen that before. And while that may not directly apply to the topic at hand, in a way it does, right? Because we're talking about quality control, and we're really talking about striving for zero defects. What better way to have a better handle on kind of where things are in the supply chain is if from a production standpoint with a pinpoint degree of accuracy, how effective and repeatable your manufacturing is going to be. And everything I think you mentioned along the way there is just another clog in that machine going along. Okay, yeah, maybe a little bit of a stretch, but I'm trying to pull it into the topic at hand here. But I really legitimately do think it pulls in there as well. So with that, and collecting, the different sensor data and everything that's on there, of course, that goes to the what I would consider one of the behemoth topics. It's kind of like the big data, but apparently big data was so, last year, kind of looking forward. I know it's not as much in the mainstream, but looking at the topic of IIoT. So IIoT, of course, is the collection of all the different sensors and other types of things. But how does all this tie together with IIoT as a whole? And Heather, I know Schneider and what you deal with. There's a lot connected there. Maybe you can give us an idea of what your vision and how IIoT plays in this grander ecosystem.
Yes, and what a great conversation we've had. I think of IIoT as the smart thread that really makes it all possible. And I can kind of even visualize it and see it. And as we speak to AI, and I listen to each one of these conversations, all of the innovations are made possible by all of us, whether it's in our manufacturing or for our customers, by sharing of the data, and that starts with IIoT. So when we look at the integration of AI and we look at the IIoT of quality control, let's say purposes of empowering our manufacturing to, again, go back to what we started from to achieve the zero defects, we leverage the real-time data analytics. We take that proactive maintenance strategies. We are continuously learning. I heard that, Marcia. And then us as manufacturers, our customers can then enhance the overall product quality, customer satisfaction, and then the operational efficiency. So again, it's the trifecta. I think I've heard many of us say that. But it is exciting, and I'm so honored that we're having this conversation, to be a part of the conversation, because it does take personal responsibility. It does take culture. It does take the awareness and the opinions and looking to the horizon. But it's very real. And like I was saying before, when I walked on the floor and I could, just see the excitement from individuals starting to come to fruition with, what they've been able to apply, or using a camera and a robot to be able to go down and see what's happening. It is truly remarkable. So I only can say that I'm not only impressed, but I'm excited for the future and what we can continue to do to solve all of this, and how important it is for us to have these conversations to learn and prepare for it.
That's good. Thank you so much, Heather. And
Totally
I think that's a great way to kind of like capstone a lot of these different topics here. We're very quickly coming to the end of the session here, and there are a couple of questions that I saw come in through the Q&A section. And while we don't have time for all of them, there is one that I think would be good to open it up to the panelists here and see what you guys have to say. So there's a gentleman named Carlos who asked a couple of different questions, but one of the big ones that I thought would be good is, and Heather, I think you touched on this a good bit, is, upskilling workers and these kind of things, and making people, giving people maybe more or higher, losing the words, but a job that's not just, moving this here to there. What is something that somebody can do to try to become better in this AI space, particularly when it comes into this quality control and leveraging, striving for the zero defects? Anybody have any comments with regard to something you can do to try to upskill in this area?
I mean, for myself, I think it goes just with the basics of just continuing to learn. How can we improve? How do we ask the questions? I mean, we talked so much about just the old algorithms that we have, that we're gaining insight, that we're taking a look at operations. I have to correct myself as well, because I spoke of the individual that works in Lexington. He actually is 65 years with the company, not 45. So if you think about someone like that who's been a part of a factory that it's been there since it's almost beginning of time, but to have the capability to take the IoT and the AI and not have a cell phone, like, again, that's remarkable. Yeah. I love even just these conversations. I lean into them as well. So I look forward to being a part of the club, because this is how we learn.
Right.
I have a similar example to Heather, where we were training operators on a plant floor on tablets to do their new work process digitally. And this particular individual didn't even have a smartphone, so she was terrified. But I think once you get them to understand how the tools, both the tablet itself, but actually the software helps them improve their job, they're all in and they're willing to learn it. So it really takes a passion in a way, but also showing how the value applies to them particularly.
So it sounds like it's really like just jumping into it, thrusting into it, embracing it, and these kinds of things. So, Eric, did you have something to offer? So yeah. So
the AI stands for augmented intelligence, not artificial intelligence.
I like it. Sorry. Yes. We're redefining things here. Actually, I actually really do like that. That's great. I mean, it's a theme of a lot of what we've said here today. So that's fantastic. It's fantastic.
Yeah, the center of the universe is the first line worker, right? So if you have a good AI system, it shouldn't be complex. It should be good, right? And so yeah.
I think also you have to make sure that they're involved in the process of creating it, and that's where the adoption comes in, right? If they just get it dropped on them at the end, it's sometimes not as acceptable. But if you actually bring them in early and, try and help them resolve the problem, I think the adoption level is much better.
Well, great. Well, thank all of you. Is there any last minute questions or comments or grand proclamations from the panelists that I have here today? The last word scared everybody.
Ira, I'm just, again, sincere appreciation and to all of the panelists. Very enlightening session. What a pleasure. And Ira, I keep looking at that piano and I'm like trying to see if maybe next time we could do a jam session, because I have a feeling that you're really good on
it. Maybe one of these times. The running joke is that so I have a large family and I use it as a wonderful backdrop, but I have no musical ability whatsoever other than I get to use it as a beautiful backdrop. But my kids could come in and serenade you very, very well. So that would probably be fun. It would probably be fun.
Let's do it.
Thank you, Heather. That's awesome. Well, with that, we will we'll bring this session to a close here. And I want to thank all the panelists for, as similar to Heather said, I think it's been a fantastic discussion, and I think this has just been a wonderful, wonderful chat and kind of going down this road here. And I want to thank particularly Trek Omni for sponsoring the session, because that's what gives us tech. It's what's given us the ability to come here, and truly just appreciate their sponsorship with the session here. And please reach out to all of the speakers that you saw here today if you have any questions, comments, or whatever else. I'm sure any of them will be more than willing to engage with you in various forms to be able to answer any questions. And with that, we'll go ahead and kick it over to the next session, which is securing the evolution of cyber physical systems, which I think sounds absolutely phenomenal as well. So I may have just eaten up the rest of my afternoon going to these different sessions. So I may be on the other side there listening in. So with that, I thank you all and wish you all a great day.
Thank you so much. Bye-bye.
It's been a pleasure. Thank you.
Yeah.